All right. So today's topic for applications to soft computing is fuzzy quantifiers. We are doing the fuzzy logic unit, and in this we will today talk about the fuzzy quantifiers. Now we have already seen in crisp sets also we had quantifiers. Those particular quantifiers were the universal quantifiers and the existential quantifiers. These were the two quantifiers in the crisp sets. Now when we talk about universal quantifiers, that means those particular are used for all, that means considering all. And when we talk about existential quantifiers, it talks about some of them, right? So now when we say about the fuzzy quantifiers, first of all we all know, as we have already studied in the earlier lecture series, that is what are the quantifiers. Quantifiers are very necessary to define the predicates, to quantify the predicates. So that is why we are using quantifiers. To know about the detail regarding the quantifiers in the CRISP, you can just go to the lecture of mine in the earlier series regarding the crisp quantifiers, right? Now we will talk about the fuzzy quantifiers. As I have told you that predicates are to be defined and to be quantified with the help of the quantifiers. So quantifiers have their own importance regarding in the fuzzy sets also. Now when we have the propositions are also quantified by the quantifiers. We all know what are predicates and we are know what are propositions. Again, you can go through the lectures in the earlier sessions which we have already recorded and posted in YouTube. So there are two types of classes when we talk about the fuzzy quantifiers. They are, first one is called as the absolute quantifier and second one is called as the relative quantifier, right? So when we say absolute, I mean to say I will give a specific, a defined quantity, right? Which will be defined in the predicate or proposition. But when we talk about relative quantifiers means they are going to be related to some other quantity, right? So example, if I say or if I talk about the absolute quantifiers, I have already told you that it will give you a exact quantity regarding that particular quantifier. So this is what example, roundabout 250. So it is saying roundabout, but still it has some specification. The specification is 250. It will not go on 100 or 300 or 500, but it will revolve or it will be somewhere around 250. So it can be 249, 250, 251, 252 and somewhere around that, but not anywhere, right? Much greater than 6. So I have a specification that the particular value is not less than or equal to 6. It is much greater than that. Then we have somewhere around 20. That means it is going to give you some specification, some idea about the specific quantity that it is related to. So that are what? That are absolute quantifiers, which is giving you a absolute value related to a particular predicate. Now when we talk about the second type, that is called the relative quantifiers do not define any specific quantity as defined in the absolute quantifiers. So here we just have almost, about, most, we can say the food has almost finished, we are about to reach, most of the students. So we do not have any specific quantity which which I can relate to. If I say around or about 250 students have already registered, but when I say most of the students have registered, so when I say most of the students have registered, I do not have a specific quantity, so that particular will come under the relative quantifiers. But when I say about 250, students have registered. So I have a specific quantity to relate to. So that was called for the absolute quantifier. So these are the two types of quantifiers we are going to use in the fuzzy quantifiers. Right. Now, we are going to see the fuzzy inference. We have already seen the crisp inference. The same way we have the fuzzy inference. Inference is what? We are inferring something from the specific predicates, from the specific prepositions. We are trying to infer something. It is somewhat related, like if I say it's cloudy today, right? And the sun is not at all visible. So what will be the inference? The inference is maybe it will rain today, right? It can or it may rain today. So this is what I'm inferring from those two particular statements. So this is what inference is. Now, when we talk about fuzzy inferencing, this particular inferencing forms the core element of the fuzzy system. That means the complete fuzzy system is dependent on this inference. Why it is dependent? Because whatever we are doing, whatever the final version or whatever the answer we are getting, that is being inferred from some related parameters or some related facts or figures, right? So fuzzy inferencing combines the facts obtained from the fuzzification with the rule based and then conducts the fuzzy reasoning. That means if I said that it is cloudy today and it is raining in Delhi. So there are more chances of raining in Ghaziabad also. So the two earlier statements are what? These are the fuzzification obtained from the rule based. And what I am conducting some reasoning over it, and then I am inferring the last statement that it may rain in Ghaziabad also today. So this is what the fuzzy inference is. Now fuzzy inference does not give you a exact answer, but it has certain amount of approximate reasoning. That means some reasoning is done out here and then we get the solution. So in this inference computation, we have two important inference procedures which are called as, the first one is called as the GMP, that is generalized modus ponens, and second one is called as the GMT, that is generalized modus tollens. If you remember in the crisp inference also, when we were doing the crisp sets, the inference we do there also, and what was the inference rules we had over there? We had three rules. They were modus ponens, simple just modus ponens, then we had modus tollens, and we had chain rule. Modus tollens, and then we had chain rule. So these were the three inference rules in the crisp sets. But here we have these two inference rules or procedures which are called as generalized modus ponens and generalized modus tollens. Now we are just going to see how it works and what is the formula for these particular inference procedures. See, first one is called as the generalized modus ponens, which is the short form as GMP. Now in this we formally state, what do we formally state? We formally, if you remember the if you remember the modus ponens, what was it? It was if P implies Q, if P implies Q, second statement was if P is true, if P is true, then Q will also be true. This was the point in which modus ponens was defined, that if P implies Q and P is true, then Q is also going to be true. So these were what? If we talk above the line, these two statements were antecedent and the final inference is Q, that is called as consequent, right? That is the result of these two facts. These two facts are termed to be as the antecedent and the result form Q is called to be as the consequent, right? So this is the same concept in the generalized modus ponens. Now let's understand this. If you remember, I have already told you that if I say P implies Q, if P implies Q, what does it mean? It means to say if P is something, then Y is so, right? That means implication defines the if then rule. So here we have if X is if X is A, then Y is B, right? This is the first antecedent. Second fact that is antecedent we have is X is negation A. Then what is the final version? Y is negation B. This is the formula, I would say, or the procedure which is followed in generalized Modus Ponens rule. Okay, inference rule. So this means what? This means with the help of these two statements, I can infer this particular part. Right? What are the two statements? These two statements, that means above this particular line, these two are called as the antecedent, which I have already told you, and this particular below the line, this is called as the consequent. That means antecedents are if Y is X, if Y is A, then Y is B. Sorry, if X is A, then Y is B. And second antecedent is X is negation A. Then what do we infer? We infer that Y is negation B. So this is what we get from generalized modus ponens rule. Okay, this you have to remember. Now where I'm talking about the sets A, B, negation A and negation B. What are these? These are fuzzy sets. These four are the fuzzy sets. I'm talking about A, B, negation A and negation B. These two are what? These two are fuzzy sets. Now in this, I have already told you antecedent and consequent. Now when we talk about the membership function, how do we calculate the membership function of negation B now? Because the formula defines or inferences Y is negation B. So how do we define it? With the help of the membership function. It is defined with the help of Max-Min composition. If you remember, we have already done this Max-Min composition in the earlier lectures. You can go through those particular sessions. Of fuzzy sets, negation A and relation Rxy. That means what will be the formula for this? It will be negation B is equal to negation A dot, that is Max-Min composition, relation XY. Right? So I'll calculate negation B as equal to negation A dot product Rxy, where Rxy is what? This is the relation XY. Now, when we talk about in terms of membership function, how do we define the formula we get is mu, because mu is what? Mu is the membership function denotion. So mu negation by is equal to, as I said, this is what? This is Max-Min composition. So max brackets minimum of what? Minimum of this, that is mu negation ax comma membership function of this, that is mu r x comma y, brackets close, where mu negation ax is the membership function of negation A, mu r xy is the membership function of the implication relation, that is rxy, and mu negation by is the membership function of negation B, where we all know negation B means 1 minus A and negation A means 1 minus when I say negation B, I mean to say 1 minus B. And when I say negation A, I mean to say 1 minus A. Okay. So this is what the modus ponens rule is, generalized modus ponens rule. Now second one, we have the generalized modus Tollens. Now what is this generalized modus Tollens? The only difference here is what you are going to do, you are going to interchange these two. Here we have these two antecedent and this is the consequent. These two are antecedent and this is the consequent I get. That means here we have stated if X is A, then Y is B. Y is negation B, then X is going to be negation A. So the same thing we are going to follow. Here the same concept is there, that A, B, negation A are the fuzzy sets. And when we talk about the negation A and membership function, what will I get? I will calculate the maximum composition of set B, negation B, and with relation of x comma y. So what I get? I get negation A is equal to negation B dot product Rxy, and when in terms of membership function I define, I will get what? Mu negation A y is equal to max brackets min of this mu negation Bx comma membership function of this mu r x comma y brackets and brackets. So this is what the generalized modus ponens and generalized modus tollens rule are. So you have to do what? You have to remember these particular formulas and understand this maximum composition. All these are related to each other. You have to remember all the concepts which we have done earlier also. So according to that, you can solve the questions, right? So that is all for the today's lecture. Thank you very much.